Thanks a lot for coming. This is the last day of the conference, so you can do it. Just, one last day. I remember that in 2008, I went to the first Devoxx. It was the first time Devoxx was called Devoxx in Antwerp, and I presented Mockito at the Tools in Action track, and it was an amazing conference. I networked a lot. I met so many people that changed my life later on. And since 2008, many things have changed. For once, I don't live in Krakow anymore, so now I live in California. I work for LinkedIn. But some things don't change. So Mockito is still #1 mocking framework for Java, which is pretty cool. And today, I will talk about how we scale engineering at LinkedIn. But what does it mean to scale engineering? Basically, I want the entire workforce of engineers at LinkedIn to be able to consistently build great products and provide high-quality technology. What are the strategies we do at LinkedIn? And I'm going to focus on one strategy, on tool making, so making great tools for engineers. I'm part of the big tools organization at LinkedIn, and our goal is to enable LinkedIn engineers to win, to build great products, and maintain and keep high quality of those products. And currently, about 10% of the workforce is our tools engineers. And I'm not satisfied with that number. I think we can do more. We can scale even more. We can, in the current group, we can even support like bigger engineering groups, like maybe Google scale, like thousands of engineers. So that would be amazing. What we do is not only tools. So we also promote good practices. We also want to make sure that engineers are using the right workflows. We want to make tools and build processes so that doing the right things is easy and doing the wrong thing is harder or like not needed at all. And how it works, I need to tell the full story. So about 5 years ago, LinkedIn technology was not at its best shape. There was a lot of tech debt, and that hurted the business. So it needed to change. Otherwise, the business was really not in good shape. The inversion project was created, and the goal was to introduce quality and consistency throughout the development process. One of the chief philosophies and patterns embraced at that time was that we stopped doing this mono-repo architecture where all the source code lives in the single monolithic giant badass source repository. We decided that we need to go multi-repo. So that software components at the source code level, they live in isolated repositories, but we integrate them during building and testing at the binary level. Think about Java jars. We pull jars from other projects. We wanted to make sure that engineers will succeed with multi-repo, because multi-repo introduces also various challenges, right? So we added a bunch of tools on top of those multi-repo architecture, and we called that this set of tools multi-products. So basically, multi-product is any software project at LinkedIn. It's a multi-product. Usually, a software team maintains a couple of multi-products. You can associate a multi-product with a single Git repository, with code. What are the things what are the fundamental features that the multi-product has? Is that on Monday, you could go to work at LinkedIn in the morning. Within seconds, you can create a new multi-product. Within minutes, you can have it shipping real traffic in production, right? So this is the entire workflow is automated and provided to the software teams. And it starts with the source code repository through the code review tooling, continuous integration server, testing, deployment, Canary releases, all kinds of stuff. This is all there for you. You just need to create that multi-product. Another very important thing about the multi-product architecture API is that at LinkedIn, we know the enterprise dependency graph. We know exactly what components are used where and which teams are using components created by some other teams. And it's not necessarily the case in many organizations. Sometimes that knowledge is pretty tacit. We know that one team uses some jar or set of jars created by some other team, but there's no holistic view that you can basically know exactly in your entire organization who uses what and how code is reused across various software teams. So at LinkedIn we have that. We also wanted to make sure that we support multiple technology stacks. So imagine that, like, when you create that multi-product, this multi-product can be a Play app for some front-end stuff. It can be a JavaScript framework like Ember. It could be a Node module. It could be Android application or iOS application, whole kinds of stuff. And for all those stacks, we provide same tools for doing code reviews, for doing testing, for doing deployments. Like, everything is like sorted out. You just need to pick your technology. Like, obviously, like when new technology comes, we need to like integrate that with our tooling, but that's what we do. And then we provide this common set of tools, this abstraction layer called multi-product at LinkedIn, and that allows our engineers to reuse tools across the entire organization. That allows us to scale. And currently, we have about 3,500 multi-products. We expect 5,000 next year, so they are created very often every day. There are a couple of multi-products, so the software teams are really embracing that. Next, I want to talk about how like software change, like what's the software change lifecycle in the multi-product? Means like, how does it work that a code that an engineer works on like goes through the pipeline and finally ends up as a feature that one of our members or users can take advantage of. So we start with pre-commit code review. So this is required for software teams at LinkedIn, that like every code needs to be reviewed by a second pair of eyes. We use a review board for that, which is open source. It's heavily modified for our purposes. And it works very well at LinkedIn. So the culture of feedback is really good. So I get code review for my stuff in minutes in my team. So this is embraced pretty well at LinkedIn, and it works very well. What happens next is pretty standard stuff. So you've got some validation, like pre-commit or post-commit. And with Git, it's more about like pre-push and post-push validation. So teams have some options here, how they want to configure, whether they want to like put all the testing up front before the change gets into the master branch, or they can do something more traditional where, you know, the pre-commit or pre-push validation is rather simple, and then, you know, the integration tests and those more sophisticated validation comes next after the commit lands in master branch. But it's there, it's part of the workflow, and it's, again, like automated. Whenever you create a multi-product, it's there for you. You can take advantage. The next feature is pretty amazing. So we automatically validate the dependers. And this ties back again to that decision that we wanted to go from a mono-repo architecture to multi-repo architecture. Like, if your source code lives in those separate software components, it's hard to know if your change breaks your clients, right? And at LinkedIn, we have tools that will tell you if the stuff that you committed like breaks somebody who depends on your code, and that somebody has his code elsewhere in some different code repository. And the reason we are able to do that because we own the enterprise dependency graph. We know exactly who uses what, at which version, like across the entire organization. We also provide like a local validation of your dependers. And your dependers are, if you build a jar and that jar is used in your org by some different software teams, those are your those are your dependers, your consumers, right? And we provide you tools to validate that you didn't break your dependers. How we do that? Imagine that you work on a couple of multi-products and you have some dirty changes, you're hacking something, you're working on a feature, and you want to find out if this really works. You can actually issue a single command from your local machine. That command sends a diff of your changes, the stuff that you have been working on. It sends that to the cloud, and we build all your dependers automatically, like with those changes. And this works very well. It's very useful. You will have information whether you have broken something or not. And at LinkedIn, we embrace semantic versioning. We have to, otherwise this multi-repo architecture, I don't think it would have worked. Since we integrate at the binary level, we need to integrate with specific versions of those software components. So the version information needs to carry information. For example, a new major version brings backwards incompatible changes. But if you are just making some little changes that only bump the minor or patch version, like those are the compatible changes and they should be like rolled out even automatically. So at LinkedIn, like you are not allowed to introduce breaking changes in your software components unless you are bumping a major version. This also means that we need to have more sophisticated dependency management and dependency resolution. We will not allow a automated conflict resolution when like we have to choose a candidate versions that are from different major versions. That wouldn't work, that would be a fail. That requires like manual migration, and like the owners have to decide which version they want to use. What happens next, when all that validation have passed, new version is created. And it's very important because like traditionally in software teams, how versions are released and created. Usually there are multiple commits, the team is working for some time, maybe a week, and they decide, okay, now we are releasing a new version. Or maybe releasing is the wrong word. Now we are creating a new version, and maybe that version is good, so we will release it. So at LinkedIn, every change creates a new version of a software component. Now, it's up to the team whether they want to publish this new version and make it available to everybody. That's up to various automation, depending on the team, depending on their needs. But it's important that version is created. This ties us back to continuous delivery, where like every commit can be a release candidate. Actually, continuous delivery nirvana is that every commit is a release candidate. So every single commit is enough quality, it does not contain any regressions, and can be released. And your software, like every minute, every day, it's always in the state that is ready to ship, ready to release to your consumers. And then there is reality and there's life. Like you don't want to have your mobile app updated daily, right? So there are constraints, and there are like technology constraints, and there are like decisions that we don't want to like release that often. However, like keep that in mind that in continuous delivery, like the goal is that every commit can be a release candidate. And for libraries, let's say jars, you committed a change. It went through the cycle of validation, and then new version is created. But what do you do with that version? We have to provide some tools so that you can relatively quickly roll that version out. And why we do that? Essentially, like the version that is released, but nobody uses it, it's essentially worthless. And it applies to commits as well. Let's say you worked on a commit, and it's beautiful. It adds a new feature, it has fantastic unit tests, and it has flawless design. And this commit is essentially worthless unless it's shipped to the client and actually somebody is using it. So that's the pressure from continuous delivery, to get the stuff out, to get your software out, because then it's really useful, not when it sits in the repo. And then the same applies to the versions, right? The version, you committed a change to your Java library. New jar is created, but unless somebody is using it, it's not useful. So actually, let's go back. So what we do is we offer like automated various tools that helps you with that problem. One of the tools lets you automatically roll out that change to all your consumers. Again, we are leveraging the information. We know what are your consumers. Another tool provides you ways to like automatically manage the lifecycle of versions. You can choose to deprecate a version that causes your consumers to have various warnings and like pushes them to like upgrade to a newer version. You also have ways to end of life a version. So you decide that this version is, let's say, you found a regression in one of the recent versions. You can completely like end of life that version, and people can no longer use that. And we provide automated tools for that. And this is the workflow for libraries, for jars. For jars, in an example of like Java stack, but in different stacks, this workflow is equally supported. And for applications, we have a slightly different workflow. When the new version is created of your app, essentially, like you need to get it to your users, right? And for that, the next phase is a Canary release. So how it works? Basically, let's say your application runs on 1,000 instances. Canary release means that on a single instance, you will drop your new version of your app. And then it's this new version, this Canary, is heavily monitored. So we will know if like certain things are out of order. Things like there are some unique exceptions, like certain like workflows are different, or there are some suspicious differences and discrepancies with like other running instances, CPU usage, like memory consumption, all kinds of stuff. There are lots of signals that come from the Canary release, and usually the lifespan of a Canary is about 3 hours. And during that time, the team makes a decision whether to roll out this Canary to all the instances or to roll back the Canary. And in certain teams, this process is automated. So the Canaries, if there are no negative signals, they are automatically published. But that's not it. When you publish your application, your new version to all your consumers, then it comes to ramp up the feature. Like all of the features at LinkedIn that we build, they are launched in this dark mode. It means that the Canary release should not change any behavior of your application. And it's covered with this layer of A/B testing. So imagine that every feature that we develop at LinkedIn comes with this layer of A/B testing. And if you don't know what A/B testing is, this comes from experimentation. So when a big companies wanted to experiment and add a new feature without breaking workflows or upsetting users, they usually they had software that allowed them to present that new feature only to a certain population of users, usually a small population of users. This allows them to gather necessary information, like find out whether the user engagement is getting better, what is the feedback, and if the feedback is good, then that feature is completely rolled out to higher population or even all your users. So that comes from, that's the philosophy of A/B testing. And at LinkedIn, every single feature is wrapped within that, which means that the Canary release does not alter the behavior of the application, and only when the Canary is out and the new version is up there, serving real traffic from on every instance, we start ramping up features. The most classic way of ramping features at LinkedIn is to ramp to LinkedIn employees first. So all the apps, typically the flagship app or the LinkedIn.com changes can be seen by LinkedIn employees first. We can gather some feedback, we can dog food the changes, and then gradually, slowly roll that out in a way that it's safe. And A/B testing is essentially feature branching in code. So we don't like feature branching at the source code level at your, in Git or whatever source repository you use, but rather in code. It brings certain complexities. The teams need to be disciplined to remove old code. When you ramped up the feature completely, at some point, you should remove that layer of A/B testing from a given feature. So this requires some extra discipline, but this allows us to iterate changes in a more faster and provide avoid any regressions. So that's the workflow, and it's a little bit simplified. I think there are more boxes in real life, but those are the highlights that I wanted to demonstrate. And it's pretty cool. But how does it apply to continuous delivery? Because the workflow that I showed does not really tell you whether it's fully automated, that you have your change committed, when does it go to the end user. So last year, we wanted to implement this concept of 3x3. This means that maximum time between the commit to the production release is 3 hours, and there are 3 releases per day. And I'm not saying that the team is allowed to release 3 times a day or enabled to release 3 times a day. We want them to release 3 times a day, period. We are releasing 3 times a day. And implementing that for an application that is used by millions of users is really interesting. Imagine how much effort you need to put in automated validation and making sure that this really works, to get that level of automation. But we pulled that off. It was a hard job last year. And if you use the LinkedIn app on your new mobile experience that was delivered late last year, it's running on 3x3 tooling. And I want to highlight some of the lessons that we've learned and tooling that we have implemented to make 3x3 possible. One of the mottos of the teams that were supporting 3x3 is that they discovered very soon that flaky test is worse than no test. Who agrees with that, by the way? Oh, a lot of us. Excellent. So it's true. It was killing continuous delivery. To give you more specific example, imagine that your test is 99. You have 1,000 tests. Each of them is 99.9% stable. Can you make a guess what's the stability of your entire suite in percentage? 0? Oh, that's too harsh. It's 37%. So it's 99.9% power 1,000. And 37% just does not work. It will never work. With the constraints that we imposed on us, that we want to release 3 times a day and maximum time between commit to production 3 hours, that's a no-go. They had to make it stable, completely stable. What we've done, it was pretty amazing. So we have a ways of detecting flaky tests. How we do that? So the team discovered that, okay, we have this farm of boxes, and we use those boxes to run our continuous integration builds, our testing, deployments, and stuff. But during the night, this farm is relatively idle. During the night, California time, nothing much happens. So we can use that time. So what we do, during the night, actually we have an automated way of detecting when there is some idle capacity that we can use. We run the same tests without any change, thousands of times. And I have to tell you that if you run one test 1,000 times and you run it every day, or actually every night, you'll very easily detect any flakiness in those tests. So they've been detecting flaky tests, and they have workflow that follows that. Jira ticket is created, the test is removed from the suite immediately. That's one of the things they wanted to do. They count if flaky test has to be removed immediately. It goes to quarantine or something, and there is an owner that is responsible to either fix that test or maybe remove it, but essentially it needs to be handled. Another important thing are making the builds fast and the tests fast. You can have a reliable test, but if they take slow, you are not able to meet that window, that 3-hour window, right? So there were multiple strategies to make it possible. One of the fundamental one is heavily parallelization. So parallelize as much as possible, parallelize on the single machine, parallelized on multiple machines. Also, making sure that the tests are fast. So if they are not fast, the team was constantly cracking those tests and making sure that they are fast. In that process, they had to fix a bunch of open source tools, making them fast. They made KIF framework. They made it 20 times faster. I hope they will contribute that back to open source. And it's pretty amazing, and they made it possible. So they came from an application that ran for 5 hours, all the tests, and they didn't even have that much of coverage, to running that in minutes and having really, really comprehensive coverage so that they can confidently, automatically release. One important thing is that there is some manual testing, involved, but the manual testing or exploratory testing, it never, stops the release. The release is completely automated, right? On the way, there is some dog fooding where LinkedIn employees are using the application that is the beta version of the application, but the process from the commit to release to production is automated. Another important thing is that the master branch must be always healthy. So those teams that operate in that mode, continuous delivery, 3x3, they made sure that entire testing happens before the changes actually merge to the master branch. Sometimes when that assumption was broken, there was some weirdness introduced, there tooling in the flakiness or something that caused the code in master branch unhealthy, the build broken and stuff. That's major, that is a fatal error for the team. They just stop the production and basically we need to fix that problem immediately. There cannot be any unhealthy code, something that is not working in the master branch. This has to work. And they've done it. So I'm like quite amazed. And I was not like really part of that team. I was helping out, but it's pretty cool. And I will gladly take any questions if you have. Now. Do we use Gradle? We heavily use Gradle. We use Gradle, like, that was one of the technologies chosen back at inversion time. So like 5 years ago, where we had to clean up the tech debt. One of the fundamental usages of Gradle at LinkedIn is that we reuse the Gradle plugins and components like across various technology stacks. To give you an example, Python team wanted to like integrate, like use Gradle to build stuff. Like the build tools for Python, they are not as sophisticated as for Java. Like you guys are spoiled, Java engineers. You've got like fantastic tools. So they wanted to like add some automation with Gradle. And they did it in like one day, like in few days. In few days, they came up with the build system for Python that was vastly better than a Python build tool built with Python that they have been building and maintaining for years. Why? Because they were able to reuse some of the components, the Gradle components that we have developed for Java. So Gradle is a big win for us when it comes to scalability, because we can reuse the Gradle plugins in our stacks. We have a plugin for dependency resolution. We reuse that plugin for dependency resolution in our Python application, with our JavaScript, node modules, with all kinds of those technology stacks, which is pretty cool. We actually drive JavaScript, building JavaScript framework, JavaScript pipeline with Gradle as well, which is pretty cool. And that was a long story, but I like to talk about Gradle for some reason. Any other question? How do we quarantine a flaky test? So essentially there is a code commit, right? There's an automated commit that disables the test. And it really depends on the technology this test is written. Let's say in JUnit, we would add an ignore flag on a test and commit that change in so that the test is ignored. So that's an example. Like I don't remember exactly what was but essentially the code was changed to disable the test. Yes? Okay, so the question is, do we observe a trend where like we add more features, we need to add even more tests, and we observe that there is even more like flaky tests? I think that was the question. So absolutely. Like so when you do like more sophisticated testing, I'm not talking about unit tests. Unit tests are like relatively simple. They tend to be pretty stable. But when we talk about like integration testing, like the tests that like involves like kicking off like some server, or tests that require kicking off emulators for various devices, things like that, there are more dependencies on various tooling. So like those dependencies unfortunately like expose any flakiness. And there are also like issues with certain testing frameworks. Like for Java tools, they're like amazing, like testing frameworks, but for like certain other technologies, especially if you go to like iOS and Android, like not necessarily like all the tooling is yet that mature, because those technologies are not that, as like let's say mature as the Java tools. So we see more tests, then we see more flaky tests, but then we like work hard to like avoid those flaky tests and like fix them. And like that's like the presence of flaky tests is unavoidable. So like you have to like keep in mind that flaky test is a part of our like engineering culture. It's always going to be there. Like no matter how much craftsmanship you put in code, there's always certain things that you will miss, or someone misses, and there will be like a flaky test that fails occasionally. So that will happen. And then the question is what's next? Like what are the tools that you can and processes you can put in place in your team to make that to make those flaky tests not like hurting the productivity of your team. Any other question? I'll repeat the question. So.
Okay, so when you release a version of a library, who updates the defenders? I know the defenders, but who makes the updates?
So it's a great question. So if you release a new version of your, let's say, Java library, and you have 100 consumers, like who like bumps their version? So you have two options, essentially. Either you do it yourself, which is basically use a tool that we provide that, hey, I want to bump this version in those consumers. And that's one option. Another option is that you like set a deprecation date for a previous version so that they will get a warning, so they will have to do that. Like this second approach sometimes does not work because like sometimes team, they don't care about the deprecation messages and at some point, oh, it's failing, we need to fix it now. So, not necessarily it's always like completely smooth. But like the difficult problem here is that when you have a conscious major version change, right? Because major version change, let's say you go from 1.5 to 2.0, and then you want to release 2.0 because you have some breaking changes. You removed some deprecated code. You have changed certain behavior that the previous behavior maybe was not wanted. So what do you do next? Because you can't really automatically like publish that change because let's say those consumers, they have to change some stuff in their code base. So this is hard, and we don't have like a good story for that. Like usually we do it traditionally, so there has to be a release notes with that contains information about breaking changes and how to what to do with those. But we are working on a tool that allows like library owners to submit some automation that can automatically migrate your users. So if you know what they need to do exactly in order to migrate, I don't know, like change some interfaces they implement, you could submit this sort of automation with that in some way, and that could automatically roll out that change, applying some changes in their code to make them working with that new version. Okay, another question? Great question. Sorry, I didn't. So the question was, what does it mean pre-commit code review? So basically, you have two kinds of code reviews. If you use formal code reviews using any like tools like Crucible or like code review or whatnot, one is that it happens after the fact that the code was committed. So the code is already in the master branch, and at some point later, like somebody reviews that change and gives feedback. That's post-commit, like post-push. The code is already there. Now, pre-commit or pre-push is basically that the code does not end up in master branch unless it's reviewed. So review must be first. So there's no unreviewed code checked in at all because it's not possible. In our workflow, you have to review first. Make sense? Basically, imagine that. You cannot commit. You have to wait until somebody ships your change, blesses your change. It's good stuff. And then you can commit. Oh, how many people need to bless your change? In our workflow, it's enough that it's one person, but this person needs to be like an owner of the project. So there's a list of owners of a project it's part of the metadata of the project. What are the owners? And they need to like bless this change. We call it ship it. There's like a big ship it button. Ship it, and then somebody can commit that. The question was whether we push to feature branch or to work together. So it's up to the team, really. We have a tool for those pre-commit code reviews. So what happens is when you made your change, you basically submit this change to review. Like you have a command line tool that you invoke one command line operation, and it sends the diff out. It's in this tool, and your teammates are notified. They get an email, and they can take a look, and they can review that in the tool. It's online tool, so it's a web application, and they can say, ship it, so that then you can check that in. We don't push it to the repo. I mean, you can, if you want, let's say you go on holidays, you have a lot of code, you can push it to like a branch, that's fine. But the branches are not like processed with they are not a part of the workflow. If you want, like if the team wants to like develop in feature branches or developer branches, which I don't like and we don't encourage, they can. But the main process remains the same. So like all the code that goes to master has to be reviewed with that formal tool. So like for each code review has like an ID number, there's a metadata attached to this ID number, like whether it was reviewed, when. We we collect a bunch of statistics about like code reviews. We want to know if teams are leveraging like code review well. So if like we want to get the time to review as like short as possible, so that you have a natural flow. You're not like waiting for weeks or on a review, but it's really like minutes when you get a review. And like using this online web code review tool does not mean that we don't like work together or pair program. We also do that. But like at the end of the, like sometimes what you can do, you can call someone, hey, I have this stuff that I was working on, and you guys both discuss the code. And then at the end of that, you submit that RB, like the other person has to like ship it, has to bless it, and then you check that in. But the entire review process happened when you guys were pairing. So that's also what we can do, pretty standard practice. But there is a trace. There is a code review, official code review that is out there, posted to that web app. You can see who reviewed that, and then the commit is allowed to be checked into the main repo. Yep. It's a great question. So it's about like a test environment and integration testing, given like microservices architecture, like how does it work at LinkedIn? Like I didn't talk in many details about it, but we have pretty sophisticated tooling for doing like various kinds of integration testing. So like we do, and this also depends on technology. Like obviously for different technologies, you have different ways of testing things. But essentially, like if you develop like microservices that are leveraged by, let's say, the main site, linkedin.com, you have ways to like deploy your changes to like staging environment and like see how it works with like all the like other microservices and like entire app. You have ways of like tying your local environment to your staging environment pretty automatically, that essentially like you work on your microservice, but you have some dependencies and you have some dependers, and you don't really know how your change is affecting someone, and you want to validate that. So you can actually make it so that you sort of connect your local environment with the staging environment, and you you basically get your dependencies from that staging environment. So it's one of the examples. We also invest a lot in really fast like integration tests. Like, you know, how can we make the integration testing like successful and stable and fast? But like do like as fast as possible. And you know, basically we have to limit the amount of like end-to-end like automated testing. That's just like end-to-end automated tests is just no, that doesn't work. In continuous delivery, you have to figure out how like push as much as like testing to the right levels. Like a lot of unit tests, right? A lot of like those fast integration tests that sometimes are not. Those integration tests may not reflect the reality. They might use some of the stubs, some of the stub servers, but we lose a little bit of credibility, but we get stability and speed, which we need really. So I hope that answers your question. I could do probably a talk about like how we do testing stuff. So any other question? You'll be next. What tools do we use for integration testing? Yes. It really depends on technology. Like, I don't know, like you have your ways of doing things, like what tools for integration testing on, let's say, Android or iOS. So you have your emulated devices and stuff. And you have some like frameworks, like Key framework, for example. For Java and microservices, like we are based on like RESTly, which is like an open source technology. That LinkedIn uses. We have ways of doing those integration tests. So we basically implemented, we rolled out tools for that. We leverage as much as possible from the other tools, but like I can't give you like one. Like there's a lot of stuff. Okay, there was a question over there. Absolutely.
And what do you do in case of rolling back?
Rolling back changes on persistence layer. I'm not sure I would be like completely comfortable like answering that question because I might not know, but let me try. So like rolling back, absolutely we need to be able to roll back, and our tools support that. So you have ways of rolling back your your Canary release, you have ways of rolling back your like full release. Like sometimes it's really hard to roll back because like if your change depends on like, I don't know, it's complicated to say, but sometimes it's really hard to roll back a change because the change is so connected to other changes that is really, it's kind of hard to like roll back that change. So like sometimes there are challenges and we have to maybe like roll forward like a fix. So that's also something that we need to do sometimes. It really depends on the nature of that like regression of that problem. For Java libraries, if you like publish a new Java library and it's bad and you did not detect that regression early enough, what you get is you basically end of life that version. And then, you know, your consumers will not be able to use that. I hope this answers your question. I know that I don't get into many details, especially with this persistence layer, but we automated as much as possible with that, so that to make it possible, rollbacks possible. And one last thing is that actually the ability to do rollbacks is one of the chief reasons we moved from monorepo to multi-repo. With monorepo, it was really hard to like roll back changes because all commits get into the same repo. Like it's really hard to find out like which one is broken and like whether you can safely remove that commit or roll it back. With multi-repo architecture where we integrate at binary level, like, and then we embrace semantic versioning and like minor versions do not break, then we have much better way of accomplishing rollbacks. Another question? Excellent question, thank you. So how did we do like a dependency at the enterprise level? How does LinkedIn do it so that we own the dependency graph, we know who uses what? Basically, we have an extra metadata that is attached to every multi-product. This metadata contains the information about dependencies. So it's a file in some format that like computers can easily parse. Unfortunately, it's JSON, but you know, and it has those dependencies. And the way it works is that they describe some high-level metadata about the project, so like dependencies, and then in your sub-modules, like depending on your build system, you refer to those dependencies. So that's the way. We have this little bit of an abstraction layer. It's a file, it's a metadata, and we ensured that like all stacks that we have integrated, they work with that file. So it's pretty cool. So you declare dependencies in your, we call it product spec, this metadata file, and you declare those dependencies in the same way for Java, for iOS, for JavaScript. Like you have a consistent way of declaring your dependencies, and this allows us to like have this like tooling that that work with various technology stacks and understand dependencies across various technology stacks. How long does it take to like build those tools and I guess maintain them and offer them to engineers in a big organization? It's endless. You never stop. You keep investing in tools. You keep building tools and making them better, making them great. Like all the tools that we provide, our goal is that they are like completely stable. There's no tooling flakiness. It's really hard because we have so many tools. And also like that they provide like delightful developer experience. Like we want the engineers that come from like other companies or open source and they come to LinkedIn and they see the tools that they have to do their job to like make that commit go through that pipeline and get shipped to the user like really smooth and you know working. You mean like how long does it take to come up with an idea for like a feature in product? So in how much does it take to like change that and introduce some new changes to that workflow? It really depends. It's really hard to say. Depending like what do we want to change. Like sometimes we change some fundamental features. To give you an example, we want to change the way our dependency testing works. So like at LinkedIn, we have a way of automatically detecting regressions by rebuilding all your customers with your changes, right? But let's say we want to change the way it works. So that's like really fundamental change. Like we want to And then that takes more time, and then that requires like multiple components of our tooling, like ecosystem, to be changed. Really depends. Essentially, you know, we work hard to get it working, to get it like really working for engineers. Yep. Okay, so what does LinkedIn do with those tools, whether we sell it, open source it, and like only use it internally? We try to open source, like there are some famous open source that came from LinkedIn, like Kafka, for example. But like reality is that sometimes it's really, you know, connected to LinkedIn so much that it's hard to open source. Like sometimes we implemented certain tools without like open source like in mind. That makes it really hard to like re-engineer that so that it's good to be open source. So for certain tools, and one of the examples of that tool is this whole concept of the product spec, that we declare the dependencies for your products in consistent fashion across multiple technology stacks. It's kind of late to like open source that. We would have to put a lot of effort for that. So like it's not in the plans. Like I would love to like open source as much as possible, and we would, given time and budget and like everything, we would love to like open source like entire like workflow that we have. But it will be hard because that's a lot of extra effort. Some teams do that, some teams don't. Definitely like leadership and management is definitely in favor for doing a lot of open sourcing. Any other question? It's a great question. So what happens if we have dependencies between services or like software components that are not declared in those files? Can they still like talk to each other or like integrate? The question is yes. Like there are ways to like ignore our tools and like do things in more like hacky way, dirty way. We like offer various of like validations and checks to like prevent that. We try not to be like too opinionated, because maybe there is a reason a team wants to hack or experiment. This situation that you described, that it is not really happening. Like I have not seen that happening, because usually. Yes, but it's true. Like you could say that if for some reason team forgets to declare a dependency, but they still use that dependency, we will not have that information. So we will have an inaccurate, dependency graph. But that happens rarely. And for certain technologies, it's even impossible because we have some checks that prevent that. So it's really, it's pretty rare, because like the team benefits from like declaring those dependencies. So it's kind of in the spirit how we build those tools. We want the tools to make it easy to do the right thing. So it's easier actually to declare those dependencies and work with them like if they are declared at the high level than not to. Oh, it's a good question. Whether we can use Gradle to like find out this dependency. Like we could leverage Gradle, and we leverage Gradle to a large extent. Like, however, the multi-product needs to be something that is like built to agnostic. Like it needs to be on higher level than Gradle. It needs to work with like other technologies, not only Gradle. It's kind of funny, because when we initially like created that multi-product API, the intention was, let's try to use Gradle. And like 5-6 years ago, Gradle was not really very mature, like it was pre 1.0. We didn't know if Gradle would be a big thing. So we just used it for Java, right? But over the years, we have discovered that we essentially like building and running all kinds of software, including native stuff in C++ with Gradle. So in theory, like Gradle could like advance and become this layer, this big layer. But so far, like we have no plans for that. We are kind of happy with that abstraction, that in theory, you can like replace Gradle with other system, and still our tooling would work. But that's kind of unlikely. Maybe it's too late for LinkedIn. We implemented so much stuff in Gradle that it's just too expensive to use something else. But we are very happy with Gradle. Gradle in LinkedIn ecosystem is like really like stable and like really like great technology. Maybe it's because Gradle is so good with It was very good for Java. Like Android team decided to use Gradle for their automation. That meant huge deal for Gradle, and that actually made Gradle successful and be like massively adopted. So we're happy, very happy with Gradle so far. And we're looking forward to 3.0 that was announced, I think, today at Gradle Summit in California. Or yesterday, or maybe, yeah. And now, I don't have any time for other questions, so thank you very much, and hope you enjoyed it. Enjoy the remaining conference.